Okay, today we're going to learn how to find the volume of solids using cross sections instead of rotating the region around a curve. So before we rotated around an axis or a line and we created a disk, and so we used the formula pi r squared because it's the area of the disk. Now we're going to be looking at a solid and we're going to be cutting it into cross sections that are other shapes such as semicircles, rectangles, squares, and triangles. And by the way, these notes are posted in the Unit 8 folder if you want to print them off in order to write and follow along. So these are pictures of what we're doing. So for example, they're going to say we have this solid on an XY plane and its base is on this plane. And they're going to cut the solid into different types of shapes. So for this example, they did a square. So we can see that here they're making the cross section a square. And so if we look at like the bottom right example down here, what they're doing is they're cutting this cross section into an infinite number of squares and finding the volume of one square and then integrating to find to add the volume of all the squares together to get the volume of the solid. So again, we're not rotating it to create the solid. The solid is just placed on the axis and its base is in the coordinate plane. So the example on the top right over here shows you when they slice the solid into semicircles. And then the example here on the left shows you that the base would be a circle, but we're using cross sections of a square to approximate the volume of the 3D figure. So generally, when I draw them or when you see them on a worksheet, they're just going to give you a picture like this one, the x squared plus y squared is less than or equal to 1. So they're just going to give you the base and draw one example of the cross section because it's really hard to draw the solid. And this bottom picture is the area with a ellipse bottom, but they're going to cut it into triangles to approximate the area. So the key thing is we're no longer using pi r squared unless they tell us to use a circle or a semicircle. So how we find the volume is we take the area of whatever the cross section is and we multiply by the width, and the width again is going to either be dx or dy depending on what they tell us, depending on the way they tell us to go. So a of x always stands for the area of the cross section. So whenever they say that the cross sections are perpendicular to the x-axis, we're always going to integrate with respect to x. And if they say that the cross sections are perpendicular to the y-axis, we're going to integrate with respect to y. For instead of perpendicular to x-axis, they could say for this one parallel to y-axis, because if you're parallel to the y-axis, then you have to be perpendicular to the x. So that would also mean in terms of dx. And for perpendicular to y-axis, they might say instead parallel to the x-axis. It's not as common, but I've looked at a few examples and occasionally they say parallel to an axis instead of perpendicular. And so just like we did with our other volume and area problems, once we know if it's dx or dy for our width, we get everything else in terms of x or everything else in terms of y if it's dy. So since we're going to be doing the area of different figures, let's go over some of the formulas. So an area of a square, we just take one of the sides and we square it. That gives us length times width, which are equal. The area of a triangle, remember, is 1/2 base times height. We're going to come back to the equilateral triangle after we do the circle. And a circle we've been working with is pi r squared. For an equilateral triangle, we want to find a formula in terms of one variable because we're always only going to be able to find one side that's the base. So when we do an equilateral triangle, we want to figure out a formula for the basic equilateral triangle. So if I call my bottom side S, we know an equilateral triangle, all the three sides are equal and the three angles are each 60. So to find the height, because remember a triangle again is 1/2 base times height, the height has to be the altitude, it has to form a right angle. And so if we draw the altitude, what happens is it cuts the top angle in half, and so we have 30. And so then we have a 30, 60, 90 triangle, which means we can find the height in terms of the base. So we need to find the side of the 90 triangle. So this side would be divided by 2. So this is S divided by 2 would be this side of the right triangle. And then to find the height, we would do our 30, 60, 90. So if we remember back to geometry, or even last year when we did 30, 60, 90, the ratio is 1 square root of 3, 2. So we have the side across from the 30. We want the side across from the 60. So to get that, we take the short leg and we multiply it by the square root of 3. So this height is going to be the short leg, which is S over 2 times the square root of 3. And then remember, our base again is S. So to find the area, it would be 1/2 the base, which is S, and then the height, which is S over 2, the square root of 3. You don't necessarily have to memorize this formula, but you do have to know how to figure it out if they ask for an equilateral triangle. It's rare, but we are going to do one example like that, and I think there's another example on the worksheet. So just be familiar with how to find the area of an equilateral triangle. So here are the steps for the volume of a cross section. So we'll go through these steps as we do the first problem, but if you want to pause and read through them, you can, but I'm just going to use them when we do our next problem. So this first problem is not on the worksheet, the other ones will be, but they tell us we want to find the volume of a solid that lies between the planes perpendicular to the x-axis at x equals 0 and x equals 4. The cross sections perpendicular to the x-axis between these planes run from one side of the parabola x equals y squared to the other. The cross sections are squares and their bases in the xy plane. So we have a square, and the bases of these squares are in the xy plane. So they're cutting across like this. So this is the bottom of the square. So this would be like the bottom of one square. And they drew the square on the side. So if we look at this, we need to use our formula for A of x, which is the area of a square. So area of a square is the side squared. And so our one side is the distance between these two curves. So we know this top distance is square root of x. And we know the bottom distance is negative square root of x, because this is a negative y value. And so if we want to find the length of that side, if we want to find s, we can either say it's the square root of x minus negative the square root of x, which is 2 the square root of x. Or you could also just think about it as the top section, which is square root of x, and multiply it by 2 to get the whole width. So that's one side. So A of x, the area of that side, or that square, would be 2 the square root of x squared, which is 4x. So this is the area of one square. To get the volume of that square, we would say dv is equal to 4x times the width, which is dx. And the reason we're terms of x is because they said it's perpendicular to the x-axis, which means we're in terms of dx. So we did all the steps up to write dv in terms of x or y, and then we want to write the integral for the volume. So we're going to add all the discs by taking the integral of 4x dx, and then again we're in terms of x, so we need to do our x bounds. So if I look on my x-axis, I'm starting at 0 and I'm ending at 4, because they told me in the directions it's bounded by the curve and x equals 4, and x equals 0 and x equals 4. So that's my starting and ending point. And then we can either integrate it by hand, or we can integrate it in the calculator, but since this is the easy one, I'll just do it by hand. So it's 4x squared over 2 from 0 to 4, which is 2x squared from 0 to 4, and then I'm going to use the fundamental theorem of calculus to plug this in. And remember, on a free response exam, you could stop there, but we'll just solve this. So we get 16 times 2, which is 32. So our volume of this cross-section is 32, and they didn't give us units, so we don't need to put them. Okay, so the second problem, we have a region bounded by the graphs y equals x squared and y equals 4, and they want us to find the volume of a solid that has this region as its base if the cross sections are rectangles with a height of 4 and the cross section is perpendicular to the y-axis. So if we look at our steps, if we go through all these steps for this one, the step 1 says draw the region of the base of the solid. So I'm going to draw the graph of y equals x squared and then y equals 4. So this is y equals 4. So that means this point is 2 and this point is negative 2. Then step 2 says draw a representative slice of the solid with the correct orientation and note the thickness as dx or dy. So they told me I'm perpendicular to the y-axis. So that means I'm going to draw my square, my base, the base of my rectangle this time, as perpendicular to the y-axis. So this would be the base of my rectangle, and since it's perpendicular to the y-axis, this is dy, the change in y. Then the next thing says draw the shape of the cross section, so I'm going to draw that to the side. Because if you want to draw it on the figure, if you're good at drawing 3D figures, you can, but we all know that I'm not. So this base down here, this length, the base, is this distance in our plane. So this is B as well, if I mark that so we know. And then they said it's the height of 4. So the rectangle has a height of 4. And then it said label the important measurements of the solid in terms of x or y looking at the base. So we need to figure out the base, and we want to be in terms of y because we have dy. And so we want to also think about the area of a rectangle. So the area of a rectangle is base times height, or length times width. So we know that the height is 4, and we need to find the base. So if we look at our picture, well, this distance would be x, and this distance would also be x. It would technically be negative x, but since we're going distance, so the length of our base would be 2x. The other way to think about it is to find this distance is we can always subtract them. So our base would be, if we did subtracting, the length of this, which would be x minus a negative x, which again is 2x. So this distance would be x, and then we're talking about this point would be negative x, and so x minus negative x would be 2x. That's the other way to think about it. Now, we said that our base, if we do dv, if we write our dv, it would be, if I combine like terms, 8x dy. So we need to get it in terms of y. So again, you don't have to ever put it in terms of x. You can skip. So we need to solve this equation for x. So if we do y equals x squared, then x is the square root of y. And it's technically plus or minus the square root of y, so that's how we get our positive and our negative one. And because we're talking about distance again, we're going to do the positive, so dv would be 8 the square root of y dy. So if you put it in terms of y right away, it would be the square root of y minus the negative square root of y, which is 2 square root of y, which is what our base would be instead of 2x. Then we want to write the integral for the volume, so we're going to integrate 8 the square root of y dy to add up the height, or add up the volume of each rectangle, and we need our bounds on terms of y. So we look at our y-axis, the lowest value is here, which is 0, and the highest value is here, which is 4. And then we can use our calculator to integrate this one. If you want to integrate it by hand, you can as well. But I'm just going to plug this into my calculator. And we get 42 2/3 as the volume of this region. Okay. The other three examples are on the worksheet that I gave you in class. They're on the back side, or on the second page. So the first one is on the second page of worksheet number 4. So for all of the problems on the front, you're using this region. So we're using the region bounded by x equals y squared and x equals 9. And they want the volume of the solid of R, and the cross sections are perpendicular to the x-axis for each one. So again, following our steps, we're going to, they already drew it for us, but if we want to draw it again, just in case they're drawing, we would draw x equals y squared and x equals 9. And we want to find the volume of a solid that has cross sections perpendicular x-axis, so the base of the cross section is going to be this distance. So they drew it here, our y-axis and our x-axis, and for yours on number 4, they want the area of a semicircle. So if we talk about the area of a circle, a of x is going to be pi r squared. So we have to remember our radius is going to be our distance from our curve to the center of the circle, which is going to be at the x-axis. So only one side is our radius. So we only need to find the length of one. So if we are perpendicular to the x-axis, we know that dv is going to be in terms of dx. And we know that we have to get everything in terms of x. So I'm going to solve this for y, and again it would be plus or minus, but we'll just do the positive for our radius. So we're going to take that, and then we're going to do, okay, so we need the area, so we're going to do pi, and we have to figure out what our radius is. So our radius is this distance here, which is just the height of the function. So our radius is technically y, and in terms of x, that's the square root of x. So we're going to have pi, the square root of x squared, and that's going to be the volume of one of our cross sections. And so then for the volume to find the volume of all the slices, we integrate. So we have pi x, if I square the square root of dx, and I'm going to integrate on my x bound. So again, we're starting at 0, and because they said x equals 9, that's my ending point. And then we can either use our calculator or integrate it by hand. But the only thing is, and I missed this, so it says semicircle, so the area we have to divide by 2. So this whole thing I need to divide by 2. So because it says semicircle, we take the area of a circle and we divide it by 2. So then if we integrate this by hand, we would have, I would have the pi outside, and it would be x squared over 4, because I would add 1 and then divide from 0 to 9, and that would be 81 pi over 4 minus 0, if I plug that in, which is 81 pi over 4. So that would be our volume of this region that has cross sections as circles. So for number 6 on your worksheet, then we have our equilateral triangle. So this is usually one of the most difficult ones just because the formula is harder. So we are finding the area of an equilateral triangle, and its base is in the same region that we just did. So they drew the graph for us, and so we need the area of an equilateral triangle. So remember, before, if we do this again, just in case you can go back to the first slide and just pull it from there, but if you don't remember, you can always do our 30, 60, 90. So remember, the base we said was s, so this side is s over 2, which makes the height s over 2 times the square root of 3, because in a 30, 60, 90 triangle, the 60 side is always the square root of 3 times the short leg. And so then the area would be the base, 1/2, the whole base, which is s, times s, the square root of 3 over 2. Which if we condense this, it would be square root of 3 over 4 times s squared. So that's technically the area of an equilateral triangle. So that's what we're going to use. So we need to find s, and so S is this side in our equilateral triangle. So to find that, we need this distance. So remember, this curve is the square root of x. This is negative the square root of x. So we're going to find a of x, and because we're again perpendicular to the x-axis, it's in terms of dx. So dv is going to be in terms of dx. Ax is going to be the square root of 3 over 4, and then my side is going to be this distance. So we can either think of it as 2 times the square root of x, because we have it here and this is the same length, or we can think of it as the square root of x minus a negative square root of x, that distance, which again is square root of 3 over 4, and that's going to reduce to 2 the square root of x. So that's my side. So my area is this squared, and so my volume is the area of the cross section times dx. And so we're going to integrate again from 0 to 9 because those are my x bounds. I'm going to condense this, so I'm going to have the square root of 3 over 4 times 4x dx, and if I simplify, then I just get the square root of 3x dx. And then again, if you want to use your calculator, you can, just so that we practice doing it by hand. Square root of 3 is a constant, so I can pull that out in front of the integral, and then I'm just integrating x, which is x squared over 2. And then we're evaluating from 0 to 9. So I have the square root of 3 times 81 over 2 minus the square root of 3 times 0 over 2. And so we just get the square root of, or 81, the square root of 3 over 2. And we can leave it like that. You can actually stop at this point on the AP exam. Okay, the last problem I want to do is the trapezoid. This is number 8 on your paper. So we need to remember the area of a trapezoid, which we've been working with the whole time this year. So it's 1/2 the height, and then b1 plus b2. And we're using the same curve, so we're using x equals y squared and x equals 9. So they said a trapezoid, its lower base, so we'll say this is b2 and this is b1. My lower base is b2. It's in the xy plane, and then the upper base is equal to, so b1 is equal to 1/2 the length of the lower base, so 1/2 of b2. And the height is 1/4 the length of the lower base, so h is 1/4 b2. So we want to get this all in terms of x because we're perpendicular to the x-axis. So again, dv is going to be dx. This is going to be a long equation. So the area, we're going to use this 1/2 height b1 plus b2. And everything's in terms of b2, so we have to figure out what that is. So again, b2 is the distance between the curves. So this point is square root of x. This point is negative square root of x. So b2 is going to be 2 the square root of x. If you want to think of it again as just subtracting the curves, it's square root of x minus negative square root of x. Or you can think of it as just the square root of x times 2, since they're equal. So then we're going to plug that into our area formula for our dv. So we have 1/2, we need the area across. So the height is 1/4 times 2 the square root of x. Then we have b1, which is 1/2 times 2 the square root of x. And then we're going to add b2, which is just 2 the square root of x. So we have to integrate this whole thing, but we're going to simplify it first because even in your calculator with all the parentheses, we might mess this up. So we have here, if we condense the height, we have 1/4 times 2, so that's 1/2, and then we have 1/2 times 1/2, so we have 1/4 the square root of x. And then in parentheses, we have 1/2 times 2, which is just the square root of x plus 2 the square root of x. And if we condense our like terms there, we have 3 the square root of x, And so we end up completely condensing it to 3/4, and then the square root of x times the square root of x is x. So it simplifies nicely, and then we have to integrate to get the whole volume of every slice. So we integrate again from 0 to 9. We're the same bounds because we're starting at 0, we're ending at 9 at 3/4 x dx. And then if we integrate by hand again, it's going to be 3/4 x squared over 2 from 0 to 9. So that's 3/8 x squared from 0 to 9. So that's going to be 3/8 times 81 minus 0. And if we plug that in our calculator or multiply it, it's 243 over 8. But you can again leave it like this for the free response. So that is all the notes on the cross sections. There are 3 problems in your book. Please look on the calendar, the updated one in the Unit 8 folder, to know which book problems to do for the textbook work. And then you can, if you want to try a few more examples on this worksheet, we're going to be working on it in class. And then you should also start working on the sample assessment to get ahead and start studying for the next test. And that is the last unit of calculus. So we're done learning new things before the AP exam.